Hello students, hope you are all fine. We have started chapter force and pressure, rather half of the content we have already done. Okay, now this we have already done, thrust and pressure. Hope all of you have understood, right? This all is done. See, why am I sharing today the whole of the PDF with you all is so that in case somewhere in between, if the notes you have missed in your notebooks, they all can be completed. Now today we are going to start. Yes, in the last class I left you with this, okay, that how thrust acting affects the pressure, and we discussed that more is the thrust, more is the pressure. Okay, now today I'm going to continue with the topic. Okay, how many of you have understood the difference between thrust and pressure? Yes. Thrust is the force acting normally on a body. Pressure is the thrust per unit area. The SI unit of thrust is Newton, and if I ask about pressure, then it is Newton per meter square or Pascal. Correct? One more difference if you can think of. I asked you in the last class, I have shared few questions with you, hope you all have done. So from that, yes. The third point can be thrust does not depend on area, whereas pressure depends on area. Fine. Now, there were many examples of pressure in our daily life given in your book. In the last class, few I have explained you, right? So hope all of you have done that. That is very, very important part. Now today we are going to start and understand pressure in a liquid. Pay attention everyone, be ready with your physics book. This class is going to be quite interesting because I'm going to talk up to you people regarding few activities. Okay, and these are so basic and easy activities that you can perform and you can check it in your at your home also in your daily life. Okay, so let's start with today's topic, understanding pressure in liquid. What is pressure in liquid? A liquid in a container exerts pressure because of its weight. For example, if there is a bucket, empty bucket, then the weight that we feel is less. Okay, now once I fill it with water and then I lift it up, what do I feel? I feel because of the weight which is acting in the downward direction, I feel some kind of pressure which is acting at the bottom of that. Okay, so a liquid in a container exerts pressure because of its weight. Now recently you must have played holy a little bit. If you have done that, then you must have seen that there are balloons filled with water, right? Okay, so what happens when the balloon is inflated one? There is no pressure acting inside the walls of the balloon, but the moment I fill it with water, what happens? Pressure acts on all the in all the direction inside the surface of the balloon, and what happens, the shape of the balloon gets changed. That means that liquid, that water which was filled inside the balloon, that exerted pressure in all direction inside the balloon. Okay, so this is what it is, the pressure exerted by the liquid. Okay, so a liquid in a container exerts pressure because of its weight. For example, if you try to put your finger over the end of a tap, when it is turned on, you feel the pressure of the water in the pipe, right? This is a very common activity, right? You must have done it. You must have opened the tap and you must have tried to close it with your hand or a finger. Then what you feel is the pressure which of water which is there inside. Okay, now what's the formula? Same as that of normal formula for pressure. Pressure in a liquid is equal to H rho G. This pressure is again the same, but when it is acting in a liquid, obviously there will be some height to which the liquid in the inside the container will be there. So height, H is the depth or the height which is in meter, rho which is the density. Okay, you have seen oil, you have seen water, which one is more denser? Oil is more denser. Yes, so that is what the density is, mass per unit volume. So P is the pressure unit, you all know, Pascal or Newton per meter square, just now I have repeated. H is the depth or the height, I repeat, H is the depth or the height, okay, of the liquid which is wet. Rho is the density, okay, of the liquid. G is the force of gravity, you all have understood that, I guess. Okay, this is the force of gravity, gravitational field strength. Okay, so that is what it is. Okay, now P is equal to H rho G. That means all the factors are affecting the pressure directly. Height directly, density directly, gravity directly. So we'll talk about these today while we'll be discussing few activities. I have taken the screenshot from your book so that you can also see it in your book later and recapitulate the same. The very first one is a very good example. See students, pay attention. What you can see on the screen is, yeah, we have taken two glass tubes. One is empty. The first one is empty, you can say. You can see very clearly, and there is a balloon at the bottom. Deflated means there is no air inside, there is no water, nothing inside. Next, the other one, you can see blue color. Yes, it is filled with water. There is a balloon at the bottom. What is the difference between the two balloons? What happens is here, the balloon is deflated, still it remains the same. Whereas here, the balloon bulges out. Now, what's the cause for it? The water which is present. That means this water is exerting pressure on the balloon. So, balloon bulges due to pressure of water column. This is called water column, the height of the water which is filled in the container. Clear, students? So, that means there is some pressure which is exerted. Just now I was talking to you people regarding the balloon that you use in your Holi for filling water and plate, right? So, similar it is. Fine. So, this was the first activity. A liquid exerts pressure at the bottom of its container. Now, let me take the next one. Pay attention here. Yes, this particular. Here what happens, see. There is a balloon, okay, and we fill it with air or we fill it with water. Let us consider water, okay. See, fluid for both liquid and water, the concept remains the same, okay. So, specifically we are talking about liquid in class 8. So, you will take it liquid only. So, there is a balloon filled, which is filled with water, okay. Now, with the help of a pin, we made few pricks. You can see few pricks are there. Pin pricks you have made. Now what happens the moment you make those pin pricks at different positions on the surface of the balloon externally? Yes, the water starts coming out. Is it that water comes out from all the directions wherever you have made the pin pricks? Yes. So water inside a balloon exerts pressure in all directions. That means the pressure exerted by the liquid inside that balloon was same in all direction. Okay, so this is the second activity. Okay, fine, clear, student? So what can I conclude from the second activity? From the first one I concluded that a liquid exerts pressure at the bottom of its container. Okay, second one, what can I conclude? That the pressure is exerted by the liquid in all directions, because everywhere I made a pinprick, wherever I made it, I could see that water was coming out with the same value. Okay, so pressure exerted is same in all directions. Clear? Let's see the next. Now here again I have explained you the same with one more way. See, what is that? This is a piston. When I push it, what happens? The water inside, the pressure acting is more. So what happens? The pressure increases the moment you push it downwards. This piston is pushed downwards. So what is happening? You are giving force per unit area. That means pressure is acting, and whenever the pressure is acting, the water starts coming out with more of the pressure from all these points. So if the liquid is trapped in a container and pressure is applied, this liquid was inside this container and pressure was exerted with the help of a piston. So the pressure will be transmitted, means transferred equally in all direction. I cannot say from here it will come out more, from here it will come out less. Why? Because this container is having liquid in it, and that pressure which is acting is same in all direction, equally in all direction. I have underlined also the important points. This is actually the Pascal's law. It's according to Pascal's principle, all the water that moves out from the holes received will be of the same pressure. This you will be studying in your later class in 9th. Okay, right now you're in 8th, but still I can relate the topic and you can understand Pascal's law it was. Okay, that the liquid exerts pressure in all direction and same pressure it exerts. Clear, students? For now only this much is important, but you need to know Pascal was the person to talk about it. Okay, let's move to the next. See the next activity. Now here what we have is, we have two containers, same length, but what you can see, observe very carefully, is the level of water filled in the two. Here it's less, second one it's more. So what happens? You can compare the two balloons. This one bulges out more. Why? Because the length of liquid in it, height of liquid filled in it is more. So again, what can I conclude from this particular activity? Yes, the liquid pressure increases with the height of liquid column. The more is the liquid filled inside the container, the more will be the pressure acting. That's why it bulges out more. It expands more. Clear, students? So this is the activity. One more. Okay. Clear, students? Now let me talk about the next. I said this was all about the height. Okay. Now let's talk about the next, the density. For density, I have to take different liquids. Here I am taking water in the first container, and second one I am taking mustard oil. Again, I have placed two balloons. Which one bulges out more? Second one, which is having mustard oil. The B container results in the expansion or the bulging of the balloon more because the density of mustard oil is more as compared to water. So whichever liquid will have more density will exert more pressure. Clear this? So this is the conclusion. Liquid pressure increases with increase in density of liquid. Clear, student? Fine. All these activities, what am I expecting is only these diagrams. You have not taken the whole of the activity explanation, which is not needed. This part and the conclusion in your physics notebook on the white page. Okay. All these. What I want is this diagram and along with this, what we conclude, what we can actually understand from the activity. So that is what I want. Not the whole of the explanation to be written. Don't waste your time. Do the understanding part of that, and this I want with the conclusion, and this as it is. Pressure inside a liquid with the formula. Clear? Can we move further now? Okay. Now see, there are many consequences of liquid pressure. One of that is construction of dams explained very clearly in your book. Okay. What happens is the dams are made thicker at the bottom. You can see this dam. The thickness increases as the depth increases. As we go down, the thickness of the dam increases. The reason is the height. Okay. As the depth increases, the pressure of water also increases. Okay. So the water at the bottom of a dam is at higher pressure than at the top. So if that is not made thicker, the base is not made thicker, what will happen? There are chances when this pressure is going to be more, as the depth is more, the pressure of liquid is going to be more, the dam may collapse. Okay. So there might be a flood. You must have seen tall buildings. The base of those buildings is always made what? The base is always made thicker. The foundations of building are always having larger area. What is the reason for that? Because the pressure of the whole of the building is acting maximum at the bottom, maximum at the base. So to avoid the collapsing of all the buildings due to excess of pressure, they are having larger area at its bottom. So the foundations of building are kept wide. Okay, clear this part? The base, the foundation is always kept more, larger in area. Okay, okay. Let's talk about this. Atmospheric pressure. We all can feel a kind of pressure because of the air which is present around us. We all know there is air all around us. Okay, we cannot sit without air. Wherever we are, there is some form of air present. So the liquid gases also exert pressure. Our earth is surrounded by air to a height of about 200 kilometers. This envelope of air around the earth is called the atmosphere. This definition of atmosphere you will write as it is. Envelope of air around the earth is called atmosphere. Now what is atmospheric pressure? Obviously this air which is present will exert some pressure. So air has weight. The weight of air exerts a thrust on earth. The thrust on unit area of earth's surface due to the column of air is called atmospheric pressure. So this is the definition of atmospheric pressure. Clear, student? Now one more basic reasoning question which I found important in your book. I am discussing it. It's there at the top. You can see. In do you know there are 3 points. One of these is this particular. Pay attention what it says. Pressure at any point inside a sea or ocean is much greater than that at surface. The pressure increases with increase in depth. Okay, that is why deep sea divers wear specially designed swimsuits to counter such high pressure. What will happen? You all know there is blood inside our body and blood pressure is there. Okay, it is flowing with some pressure. Outside there is water when you are inside the sea or the ocean. When you are inside the sea or the ocean, the water is also exerting pressure on our body. Now as we go down, this year in the board questions, 9th class, there was one of the questions like 2 lines were drawn. One was of say 12 meter, the other was of 2 meter. And the question they asked us is where will be the pressure more? Obviously when the depth is more. So that is what the height is more. So the same as we are discussing right now, as the sea divers have to go down also. As the depth increases, the pressure of the water outside which is acting on their body will be more. It will increase. And there are chances that their body may collapse, okay, or they may die. So to protect themselves from that extra pressure which is acting from outside, they wear specially designed swim suits. Okay, to counter means to face, to bear that, to tolerate that high pressure which is acting on the sea divers, they wear specially designed swimsuits. So what is the reason for wearing it? Because the pressure increases with increase in depth. As they go down and down deeper inside the sea or the ocean, the pressure of water increases. So to tolerate that, to bear that, to counter such high pressure, they wear specially designed swimsuits. Clear, student? This was important, so I discussed. Let's move to the last activity for the day. See activity 9 here, what it says in your book. Pay attention, look here everyone. This is a common activity. I have done it when I was in this class. Okay, what happens is, in this activity, it's very common activity, you can do it, but don't do it anywhere in your home. Do it nearby some wash basin or sink. Okay, see what happens. We have to take a glass tumbler, fill it completely with water till the top, take a cardboard sheet, postcard kind of, okay, hard sheet, and then cover that glass filled with water with that postcard. Exert some pressure for a few seconds, 30 seconds say. Now what you have to do is, you have to invert the glass and remove your hand gently from here. What will you see is, for certain time this card will stick to the glass. The reason is the pressure which was exerted from outside and the one which was inside due to water, the two equal. So for time being this card will remain the same. Why am I suggesting you to do it not at home, anywhere? Because there are chances at times students don't do it correctly and the water comes out when you invert the glass jar. So do it very carefully, okay? So what we do in this activity is, when you remove your hand slowly from the postcard after exerting little pressure, when you remove it, the pressure due to water column in the glass acts on it, and the reason is that atmospheric pressure acting upwards on the postcard from outside the glass overcomes the pressure on the postcard due to water in the glass, and it gets stick to it for a certain time, very small time, okay, and then it gets removed also. Clear, student? So this is one activity you can again do it at your home and understand, okay? And if someone can record that video and send it to your class teacher, it will be good. Okay, now let's move to the last topic of this, that is standard value of atmospheric pressure. The value is fixed, students. It's not that this is not to be learned. This is a fixed value, so you need to learn it. The atmospheric pressure at sea level on Earth's surface is 76 centimeter, or you can say 760, because we know 1 centimeter is 10 millimeter. So 76 centimeter you can say, or 760 millimeter of mercury column you can say, and that is equal to 1 atmospheric. ATM is 1 atmosphere, or 1.013 into 10 raised to power 5 Pascal. This is an important value. As a 1 mark question, the value comes. What's the standard value for atmospheric pressure? And we can also give you the unit. So it's not that anyone you can learn. You have to learn all. Okay, anyone. I can ask you in blank millimeter of mercury column. So then you need to write the correct value. Okay. Last is note. The atmospheric pressure decreases with increase in altitude. That is, as we go higher above the Earth's surface, the pressure decreases. This we all have felt. When you go up on the hill, what happens? You feel decrease in pressure. You feel breathless. The reason is this only. The atmospheric pressure decreases with increase in altitude, means height. As we go higher above the Earth's surface, the air pressure decreases. Now, what is your homework for the day, class? See, this is your homework. I have mentioned it, so no need to confuse your class teacher or yourself feel confused. See here what it is. It is revise and write factors affecting liquid pressure, definition of atmospheric pressure, standard value of atmospheric pressure as it is from the PPT I'll be sharing with you. Along with the video, I'll share PPT also as it is in the notebook, and draw all the activities explained on white sheet of notebook. Now, this when you will be doing activities part, I repeat students, you need not have to write the whole of the activity explanation. How, what, nothing. Only the activity diagram and at the bottom what you have concluded. Clear, students? There is the last topic in your book is examples in daily life. Okay? So you have to learn and do the same. 10 are there in your book. All 10 are to be learned by you and understood properly. Okay, understand all and complete it. That was all for today's class, students. Complete it. Thank you.